Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge IGCSE Chemistry 0620. So today we will be discussing October November 2024 paper 41. Okay, question number 1. A list of chemical and physical processes A to H is shown. So we have a number of processes given here. So we have combustion, diffusion, melting, neutralization, photosynthesis, reversible reaction, roasting, thermal decomposition. Answer the following questions about processes A to H. Each letter may be used once, more than once, or not at all. So whenever you have to give an answer to any question, you don't have to write the entire thing, just write the letter. Okay. All right. So number one is state which of the processes A to H happens when an acid reacts with an alkali. So when an acid reacts with an alkali, a neutralization reaction takes place, which is over here. So this is D. Which process reaches a position of equilibrium? So now this term, we use this whenever we are talking about reversible reactions, right? So therefore the answer will be F. Then it says which process involves particles changing from fixed positions to being mobile but still touching. Okay, so let's read this one more time. Which process involves particles changing from fixed positions to being mobile but still touching? So, in which state of matter are particles in fixed positions? That is in solid state. Okay, and then from solid, you're moving to a state where the particles are mobile but they're still touching, that is liquid. So solid to liquid, that could be either melting or evaporation. Sorry, my bad, not evaporation. In the case of evaporation, that would have been liquid to gas, right? So yeah, the answer is going to be just melting. Okay, so therefore the answer will be C. All right. Then which processes are physical changes? So here we have to look at the list. So we have combustion. Combustion is a chemical process. Now, the first thing that you must understand is that how do we define a physical process, or how can we differentiate between a physical process and a chemical process? So one of the ways in which you can distinguish is that in physical processes you do not get a new product, whereas in a chemical process you always get a new product. So for example, in combustion, okay, you will get carbon dioxide and water, or you can get carbon monoxide and water after combustion. But the main idea is that this is a chemical process. Okay, so combustion is not the answer. Then we have diffusion. Okay, now what happens in diffusion? Diffusion is the mixing and spreading of particles, right? That is what's diffusion. We're not getting any new product during this process. So therefore diffusion is going to be one of the answers. Okay, what about melting? Now, all the changes of states of matter, that is to say melting, boiling, freezing, and condensation, all of these processes are physical processes, because in these processes you do not get a new substance, but rather you are only changing the state of the substance. Okay, so therefore B and C will be the answers. If you also look at other options, neutralization, okay, that's an acid base reaction, you always get a salt in that. Photosynthesis, you're getting new products. Okay, during photosynthesis you get glucose and oxygen, right? Then we have reversible reaction. Again, these are reactions, so you are getting new products. Roasting is a type of heating, so that's why that's also a chemical process. And in thermal decomposition, you are decomposing a substance so that by heat, so that new products are formed. So all of these other options are chemical processes. Then it says which process is caused by gas particles colliding with each other. So this is diffusion, because during diffusion gas particles, they mix, and while they're mixing they're also colliding with other particles. So for example, let's say that this is a room and you spray perfume at one corner of the room. So what's going to happen? The particles are going to start spreading. But while they're spreading, they're also colliding with the air particles, right? So that's why it says it's caused by gas particles colliding with each other, okay? Or they're also colliding with the neighboring molecules. Question number 2. This question is about atomic structure and the periodic table. Define the term nucleon number. Now, a nucleon number is defined as sum of protons and neutrons in the nucleus of an atom, okay, is nucleon number. Then it says state the connection between the number of occupied electron shells in an atom and the period number of that element. Okay, so in short, it is asking that what is the relationship, what is the connection between the period number and the number of occupied electron shells. So we know that period number of an element represents that how many number of occupied shells are there. So if there is an element which is in period number 3, so that means that that particular element has 3 occupied electron shells. Now those shells could be fully occupied or they could be partially occupied, but the main idea is that they are occupied by electrons. So we can say that they are the same. They are the same. Or if you want, you can write in a more formal way that period number represents the number of occupied electron shells. All right. Part C. Write the electronic configuration of the following atom and ion. So here we have silicon atom. Now electronic configuration basically means that you have to mention how the electrons are distributed in different shells. So like how many electrons will be there in the first shell, then in the second shell, and so on. Okay. So if we see silicon, this is an atom. So that means the proton number will also be equal for number of electrons, right? So the electrons are 14. Now we have to distribute this into different shells. The first shell can have maximum of 2 electrons. Second shell can have maximum of 8 electrons. Now how many electrons do I have to put in the third shell? So that will be the difference between them, right? So 14 minus 8 plus 2 is 10. So 14 minus 10 will be 4. So make sure that when you add them up, they should be equal to the number of electrons. Now over here we have chloride ion. So you can see there's a negative charge over here. Originally, chlorine has 17 electrons in its 7 electrons in the outer shell, and then you have 8 and 2s, right? So that's how the electrons are distributed. But because this is a negative ion and it has one negative charge, that tells you it has gained one electron. So therefore now it has total of 18 electrons. So now we will distribute this accordingly. So in the first shell we have 2, then we have 8, and then in the third one we'll also have 8. So that will be total of 18 electrons. Okay, part D. So we have to complete the table. So we have to give, okay, the number of protons are already given for all three of them. We have to fill in the number of neutrons and we have to fill in the number of electrons. Okay, so for the first one, this is a sodium atom. Okay, now because this is an atom, it does not have a charge over here. The number of electrons and protons will be the same. So we have 11 electrons, sorry, we have 11 protons over here. Therefore, we'll also have 11 electrons. Okay, now how do you work out the neutrons? The number of neutrons will be worked out by the difference of the nucleon number, which is 23, and the proton number, which is 11. So 23 minus 11, that will be 12. Okay, the second one is fluoride ion. In fluoride ion, the number of protons are 9 Okay, the number of neutrons are already given to you. Now, what about the number of electrons? Originally, fluorine has 9 electrons, but because there is a negative charge over here, that means that we will add one more electron. So there are a total of 10 electrons. Now, over here, you need to identify that what element is over here and whether this is an atom or an ion. Okay, so there are two things. First, identify the element. Okay, that's the first thing. Then in the second step, we will identify whether this is an atom or this is an ion. So we'll come back to this later. How do you identify the or how do you recognize that which element is this going to be? Remember, the number of protons are just like a unique ID of every person. You know, like how every person has a unique identification number. Similarly, every element has a unique proton number. That is how you identify it. So for this particular element, it is 31. So let's go to periodic table. Now, in the periodic table, the numbers which are written at the top, these are the ones that are proton numbers. And how will you know that? You can see over here that the numbers increase in sequence. So for example, over here we have 19, 20, 21, 22, 23, 24, 25, and so on. So this is an indication that this is the proton number. Okay, why am I telling you this? Because look over here, in the periodic table that is given to you in the exam, the proton number is written at the top. However, the questions which are given to you in the exam, the proton numbers are written at the bottom. So you see that. So that's a bit of confusion. Okay, so that you should be able to understand and recognize in both of the notations. Okay. Now, so we know that the top number is the proton number. So let's see, we were looking for 31. So this is 31. That is gallium. Okay. Now, we'll pick up 31 from here, and you can also see this 70, the nucleon number. However, we will not use this number. Okay, let me tell you why. So we know that this is gallium, and let me just write this on the side. The nucleon number was 70, right? The number of protons in each of these are given at the foot. So I'm going to write 31 over here. Now, the nucleon number will be the sum of protons and neutrons. So that will be 69. You add both of them, so you'll get 69. Do you see that there's a difference? In the periodic table, their nucleon number was 70. However, over here, it is 69. The reason why this is different is because in the periodic table, you have been given an element. You have been given one type of gallium atom, and over here, this is another type of gallium atom. So these are two isotopes of each other. So that is why always make sure whenever you have to write the nucleon number, you add from the numbers which are given in the table. Do not just randomly pick the value which is given on the periodic table. Okay, that's the first thing of identification. Now we need to see whether this is an atom or an ion. If this is an atom, that means the number of protons will be equal to number of electrons. You can see that is not the case. Here we have 3 electrons less as compared to protons. So 3 electrons less means it has lost 3 electrons, so it gained a charge of 3 positive. So that is the complete answer to this part of the question. All right, part E. A sample of thallium contains two isotopes, Tl203 and Tl205. Define the term isotopes. So this is a question that requires a basic definition. So we can say that isotopes are the atoms of the same element. All right. So isotopes are the atoms of the same element that have same number of protons but different number of neutrons. Or you can just say but different neutrons. So here you can see this is a 2-mark question. So understand the marks distribution. This is important. Okay. This is important. And this one is also important. The second mark is for this one. Now, in some of the marking schemes, you might see that this is the only one which is required, but in some of them, you might see that both of these are required for the first mark. So it is better to remain on the safe side. Okay. Part 2 is the relative abundance of the isotopes is in the ratio 3:7. Calculate the relative atomic mass of thallium in the sample to 1 decimal place. Okay. Now we can do this in two ways. Okay, one of them that you might be familiar with is when the percentages are given to you. Okay, over here they've given you ratios, but usually they give you percentages. So we can make this into percentage. If I can multiply both of these by 10, so this becomes 30:70. So that means that the ratio is 30 to 70. So that means 30% is TL203 and 70% is TL205. So now if I want to calculate the AR value, that will be 30% multiplied by 203. So we can say 203 times 30 plus 205 times its percentage, which is 70. And now the total percentage is 100, right? So let me work this out. So we have 203 times 30, that will be 6090 plus 205 into 70, that will be 14350 upon 100. So when you add them and divide by 100, you would get 204.4. So this is the usual method that you can do. There's another method where you can directly use the ratio. Okay. So I can say 203 multiplied by 3, not 30, but just 3 was given to you, plus 205 multiplied by 7. But this time, the sum of these ratios is going to be 10. Here, the sum of ratio was 100, so we took 100 in the denominator, but here in our denominator, we'll have 10. So when you work this out, you would end up with the same answer. Okay. All right. Suggest why these two isotopes have identical chemical properties. Now, the chemical properties being identical means that they have same electronic configuration. Okay, or if you want, you can also say that they have the same number of electrons. So that can also be the right answer, because remember, the chemical properties are dependent on the electrons. That is why when you have a substance in its atomic form, it's a bit different compared to in its ionic form, because here the number of electrons have been changed. All right, question number 3. Copper 2 sulfate has the formula CuSO4. Aqueous copper 2 sulfate is a blue solution. A sample of aqueous copper 2 sulfate is made by adding excess copper 2 oxide to hot dilute sulfuric acid. Okay, so we are adding excess of copper 2 oxide to dilute sulfuric acid. Complete the symbol equation for this reaction. Include state symbols. So first of all, we have studied three types of salt preparation methods. So we had titration, we studied titration, neutralization, and precipitation. Now, since this is a transition metal, okay, this is the salt of a transition metal, so this cannot be titration. All right. Secondly, we are trying to prepare copper 2 sulfate, which is a soluble salt. So therefore, the process that we are going to use, it will be neutralization. In neutralization, you add excess of your insoluble base. So therefore, this is going to be in solid state. Your copper 2 oxide is an insoluble base. So this will be in solid state. Acid is always aqueous. Copper 2 sulfate is a soluble salt solution. So therefore, this will also be in aqueous state because this is a solution. The last product that you get will be water. Okay. Now it says state one observation which shows that copper 2 oxide is added in excess. Now you will continue adding copper 2 oxide and then you will continue dissolving, right? A point comes where you are not able to dissolve any more copper 2 oxide. Okay, so therefore we can say that no more copper 2 oxide can be dissolved. Okay, that will be the observation. Then you're going to see that it starts settling at the bottom instead of being dissolved. Describe how aqueous copper 2 sulfate can be separated from the reaction mixture. Now, if you recall the four-step method that we have studied during neutralization, the first step was that you add excess of your base into your acid. The second step was to filter the mixture. Okay, so that now you can separate, you can remove your excess base, which was not dissolved, and you can separate your solution. So the next step is going to be filter the mixture to remove excess CuO and obtain CuSO4. Okay. Now remember it says describe. It did not say, it did not ask you to state, right? So therefore do not just write filtration. Okay. So make sure that you explain a little bit. Whenever the question starts with describe or explain, that requires you to explain your answer a little bit. Crystals of hydrated copper 2 sulfate can be obtained from aqueous copper 2 sulfate by crystallization. State what is meant by the term hydrated. Now, when we talk about the crystals, right, we call the crystals that these are hydrated salts. So, what we actually mean by that is that within the crystals, the water molecules are embedded into it. So, they are chemically combined inside your salt, inside that crystal. Okay, so we can say that hydrated means that water molecules are combined. You can say water molecules are chemically combined with the salt. Write the formula of hydrated copper 2 sulfate. Now, this is something that you have to remember. You have to recall this. So, the hydrated crystals have a formula CuSO4.5H2O. Now it says describe how this crystallization is done. So once you have obtained your solution of copper 2 sulfate, okay, after that, and now you have also filtered it, now what you're going to do is you're going to heat the copper 2 sulfate solution till it is saturated. Then the second step will be allow it to cool, and hence it starts crystallizing. Okay, aqueous copper 2 sulfate undergoes electrolysis using graphite electrodes. State why aqueous copper 2 sulfate conducts electricity. Now, your aqueous salt solution is conducting electricity, right? So, why does that happen? Okay, just a minute. For some reason, the pointer is not working. All right, now it's back on. Okay, so why copper to sulfate can conduct electricity? Because within your aqueous solution, the ions are able to move, right? So remember, the conduction of electricity is related either to the movement of electrons, okay, or the movement of ions. Because there are no electrons moving around in the solution, there are ions which are moving. So we can say that the solution contains ions which are free to move. Or you can also say that the solution contains mobile ions. So instead of writing this, you can also write that. Okay. The next part is give two reasons why the electrodes are made of graphite. Okay. Now the two reasons why we use graphite as the main material for making electrodes is, first of all, it is a good conductor of electricity. It is a good conductor of electricity. Secondly, we don't want our we don't want our electrodes to start reacting with the products, right? With the products of electrolysis. So therefore, it is important that the material that I'm using for electrode is unreactive. Okay, it's not going to react with the products that are formed during electrolysis. So the word that we use is inert. It is inert. This basically means unreactive, but this is a much more suitable word for this particular scenario. Okay. Okay, then it says describe how the appearance of the electrolyte changes during the electrolysis of aqueous copper to sulfate. Okay, now in order to understand this, let me quickly tell you what happens during the electrolysis of copper to sulfate. First of all, the ions which are present are the copper ions, the sulfate ions, and then because there's also water present in it, so we have hydrogen ion and we have hydroxide ions. Now at cathode, copper ions will be attracted, okay, and then over there they will gain electrons to form copper. So you will start seeing the deposits of copper at cathode. At anode, what happens? Okay, another thing is why hydrogen is not formed. Why is it cathode? Because hydrogen is more reactive than copper. Any ion which is more reactive prefers to stay as ion. Okay, you have to keep this in mind. Any ion which is more reactive is preferring to stay as ion in the solution. So because copper is below the reactivity series, so therefore it will be forced to move towards cathode and then uh, gain ions to form copper metal, okay, copper atoms. Now in the case of anode, we have either hydroxide or we have sulfate. It will always be hydroxide. Why it will always be hydroxide? That is something which is beyond the scope of your syllabus. For that, you have to study some um, more terminologies and more uh, conceptual understanding is required. That will be taught in A levels. So you don't have to go into that. So whenever it is hydroxide and sulfate, you always choose hydroxide. Okay, so from hydroxide, you would actually get oxygen gas. Okay. All right. Now, once this happens, what's remaining? What's left behind are these two ions. Together, they react to form sulfuric acid. Now, we know that sulfuric acid is colorless. So ultimately, what happens? When you started your electrolysis, the solution was blue in color because of copper to sulfate. But slowly and gradually, when all these processes take place, the color actually fades and it will start becoming lighter and lighter and lighter until it becomes colorless. But obviously, you won't directly get complete colorless solution because that takes a lot of time. So what we can write over here is how the appearance of electrolyte changes. We can say the blue color fades, okay, or you can say becomes lighter. So because it starts forming sulfuric acid, that is why it is now starting to become lighter in color. And also because copper ions, why do you have blue color of solution? Because of copper ions. Slowly and gradually, when the copper is forming at cathode, those copper ions are now removed from the solution. So therefore, if the copper ions are removed, that means that now you no longer can have blue color of the solution. Okay, part 4. Describe what is seen at the cathode during the electrolysis of aqueous copper to sulfate. So here, remember it says what is seen. So you have to give the observation. We know that at cathode, copper starts forming, but what is the appearance of copper? So the appearance of copper is brown or pink solid. Starts depositing. Okay. Then it says write the ionic half equation for the reaction at anode. Okay, so now I have to write this. So this is something that you can recall, but let's just say that if you don't remember, conceptually, what do you know? Our starting point was hydroxide. So I'm going to write hydroxide over here. Okay, what happened? It has to lose an electron, right? It has a negative charge. It has to lose an electron. Then what would you get? You would get two products. You will get oxygen and you would get water. This is something you should know. Now what happens? You have to start balancing it. So in order to balance hydrogen, okay, I can start writing 2 over here. And because this is 2, you have 2 hydroxide ion. So that means that I would have to lose 2 electrons in total. Now everything is balanced over here except for oxygen. The charges are balanced, hydrogens are balanced, but oxygen is not balanced. So what I'm going to do is I'm going to multiply everything by 2. Okay, that's the standard rule, that if everything is balanced in the equation except for a diatomic molecule. Okay, so what you can do is you will multiply everything with 2. So I'm going to multiply this with 2. I'm going to multiply this with 2. So this becomes 4 now. And I'm going to multiply this with 2. So this also becomes 4 now. This will not be multiplied. Everything except this. Now what happens? We can rearrange this equation. So my final equation is going to be 4OH negative gives us, I'm going to move this minus 4 electron to the other side. So my final equation will be O2 plus 2H2O plus 4 electrons. So that's how you can, even if you don't remember it, you can actually form it by yourself if your conceptual understanding is clear. So I hope that this is clear. All right. The next part is state two differences seen if the electrolysis is repeated using copper electrodes instead of graphite electrodes. Okay. Now, if you replace the graphite electrodes with copper electrodes, now this is a question of purification of copper. Okay, we also studied this topic in great detail. Here what we do is that we have an impure form of impure form of copper, and we try to purify it. We try to remove all the atoms of copper from that impure material, and your impurities will be left behind. Okay, so now what will be the differences? The first difference that we are going to see is that there will be no change in color. Okay, there will be no change in color, or you can say the color remains blue. Okay, because the color was blue at the beginning, at the end it will remain blue. Okay, the second difference that we can see, so we also know from the understanding that anode is the one that has impure copper attached to it. So when the pure copper atoms start to move away from it, okay, it starts to lose those pure copper atoms. So what happens? It becomes thinner and thinner until it completely dissolves. So we can say anode becomes thinner. Okay, anode becomes thinner and dissolves. Okay, so this is the answer to this question. You can also give one more observation. You can just look over here in the previous example when we were just performing electrolysis, you had oxygen being formed, right? So that means you would see bubbles of colorless gas at anode, but in this case there would be no bubbles, no bubbles of colorless gas at anode. So that is what will be different from the previous case. All right, question number 4 is, when magnesium nitrate is heated strongly, magnesium oxide is formed. Okay, the equation for this reaction is shown. So here you have magnesium nitrate, and you can see that it starts decomposing when you heat it. It forms magnesium oxide, nitrogen dioxide, and oxygen. Now it says state the change in oxidation number of nitrogen in this reaction. Okay, so now it is very important to understand because this is something which has been updated in the recent syllabus, right? From 2023 and onwards, you will start seeing these type of questions more and more. But before 2023, you won't see these type of questions. So let's go through this one by one. We need to find out that what is the change in oxidation number of nitrogen over here from here all the way till here. Okay, so let's see. The first thing that we're going to do is we have to identify that, okay, what is the charge over here, and that is something that we can represent by X. So let's see, we have magnesium nitrate. So magnesium, we have only, okay, if I just consider 1 unit of magnesium nitrate, over here magnesium has 1 atom and it has a charge of 2 positive, right? So I'm just gonna write 2 over here. Plus nitrogen, we have 2 nitrogen and the charge on nitrogen is unknown, so I'm going to write X. For oxygen, we have 6 atoms of oxygen, so 2 times 3 is 6, and the charge on oxygen is -2. Now what is the overall charge on this compound? You can see that there is no charge on a compound. Okay, so therefore the overall charge is going to be equal to 0. Sorry. All right, so this will be equal to 0. Now let me work this out. So we have 2 plus 2x minus 12 equals to 0. 2 minus 12, that will be minus 10. So we have 2x is equal to minus 10. And therefore x is going, sorry, minus 10 was over here, right? 2x minus 10 is equal to 0. Minus 10 goes to the other side. So we have 2x equals to 10. X is equal to 10 upon 2, which is 5. So that means the charge on nitrogen is going to be 5 positive. Okay. Now, or you can write plus 5 over here. Now, what is the charge on nitrogen over here? So we're going to apply the same concept. In NO2, nitrogen has 1 atom, but its charge is unknown. We need to find that. Oxygen is 2 atoms and the charge is -2. So that will be 2 times -2. Again, on NO2, you can see that there is no charge. So that is equal to 0. So we have x minus 4 equal to 0. Minus 4 goes to the other side. X is equal to 4. So the charge becomes positive 4. Okay. So this is basic algebra that you have to perform whenever you need to identify the charge on any particular element. Okay. All right. Now it says identify the element which is oxidized. Identify the element which is oxidized in this reaction. Now, if you notice, in total, we have only 3 elements. We have magnesium, we have nitrogen, and we have oxygen. So let's take a look one by one. Over here, magnesium had it already had like it was combined with a lot of oxygens over here, right? But now over here it only has one oxygen. So we cannot say that magnesium has been oxidized. That tells you that magnesium might be reduced. Okay, so that means magnesium cannot be the element that has been oxidized. Okay, the next one will be nitrogen. Over here nitrogen is combined with, if you only want to consider one unit, so you can see nitrogen is combined with three oxygen, but over here it is only combined with two oxygen. So clearly this is not oxidation. The only other element which remains is oxygen itself. So therefore our answer is going to be oxygen. Okay, all right, the next one is part 3. Calculate the volume of NO2 gas at RTP. RTP means room temperature and pressure, formed when 7.4 grams of magnesium nitrate is heated. Use the following steps. Calculate the MR of magnesium nitrate. Okay. So in order to calculate its MR, we have one magnesium atom and its AR value is 24. Okay. So from the periodic table, you can see the AR values are the values over here at the bottom. So 1 multiplied by 24. Nitrogen, so you need to take this into account. So that will be 2 times 14. So we have two nitrogen atoms and its AR value is 14. For oxygen, we have 2 times 3, 6 atoms. So 6 times 16. So that will be 24 plus 28. So 6 multiplied by 16 will be 96. And when you add them up, you would get 148. Now the next part is calculate the number of moles of magnesium nitrate used. So over here, now there are several formulas of moles. So we need to see that what information is given to us. We know the mass, we have just found out the MR. So therefore the formula that we are going to use is mass upon MR. So therefore this will be, I don't know why this is causing a bit trouble lately, my pointer. Just a minute. All right, so that will be 7.4 divided by 148. Let me work this out. So we have 0.05 moles. Okay. All right. The next part is determine the number of moles of NO2 formed. Now, whenever you're asked to calculate the number of moles, and immediately after that, you are also asked to calculate the number of moles, but of a different substance. This is an indication that here you have to use mole ratio. Okay. Now, how do we use mole ratio? We found out the moles of magnesium nitrate, and we need to now find out the moles of NO2. So we always need to look at the equation. Okay, so let's take a look at the equation. So over here you can see that magnesium nitrate, it has 2 moles over here, and for that nitrogen dioxide is 4. So this is 2 ratio 4. Okay, so let's see, this is 2 ratio 4. So when you have 0.05 moles of magnesium nitrate, how many moles of NO2 would that be? You need to just cross multiply. So this will be x. So now we can say 2x is equal to 4 times 0.05, and now you can just divide by 2. So that will be 4 times 0.05 times 2. So that's going to be 0.1. So you can, if you want, you can write to 3SF, but you can also just write 0.1. That's also fine. Okay. All right, now we have calculate the volume of NO2 gas in cubic centimeter at RTP. All right, now when you want to find out the volume, so the volume of gas in cubic decimeter is number of moles multiplied by 24 cubic decimeter. Okay, but however, the question is about in cubic centimeter. So here you have to use the conversion factor that 1 cubic decimeter is equal to 1000 cubic centimeter. So therefore, I'm going to change my formula, and instead of 24, this will be 24,000. Okay, so that means 0.1 multiplied by 24,000, that would give us 2400 cubic centimeter. Okay, so before we continue, let me just fix quickly my pen. I don't know, for some reason it's lagging a bit. All right, so let's continue. Part B is magnesium oxide MgO is an ionic compound. Complete the dot and cross diagram in figure 4.1 of the ions in magnesium oxide. Give the charges on each of the ions. Okay, so if we look at magnesium, originally magnesium atom has 12 protons. Okay, if you look over here, so the proton number for magnesium is 12. So therefore, the number of electrons will also be 12. But in magnesium ion, which is Mg2 positive, it has now lost 2 electrons. So therefore, the number of electrons over here will be 10. Two of those electrons are already filled in. So now you have to just make one more shell, and you have to fill 8 electrons into it. Okay, so this is the electronic structure or electronic the diagram for the magnesium ion. Okay, now the charge on it will be 2 positive. Okay, now as for oxygen, originally oxygen atom has, so if you look over here, this is oxygen. It has 8 protons, so therefore it will have 8 electrons. However, those electrons that it the electrons which were lost by magnesium have now been gained by oxygen. So therefore, the oxide ion is going to have 10 electrons. Okay, now 2 of these electrons are already here, so we are just going to make 10 more electrons, but you have to be careful. Oxygen will have 8 electrons of its own, right? So it has 1, 2, 3, 4, 5, 6, 7, and 8. These electrons are of oxygen. Then the electrons which were lost by magnesium have now been gained over here. Now this is the complete structure of oxide ion, and the charge on it will be 2 negative. Okay, all right, now the next one is oxygen is a covalent molecule. Complete the dot and cross diagram in figure 4.2 of a molecule of oxygen. The inner shells have been drawn. Something very important that you have to remember is an oxygen molecule has a double bond between the atoms. In an oxygen molecule, there is a double bond between it. Double bond means that there will be two pairs of electrons being shared between the atoms. Single bond means one pair of electron. Okay, one pair of electrons. So one from this oxygen, one from another oxygen. But because there are two bonds, there's a double bond, so that will be two pairs. So two pairs means in total there will be 4 electrons being shared. So let me first draw 4 electrons over here. You have a dot, cross, dot, cross. Now let's see. 4 electrons are already here. So now I have to draw the remaining 4 because you can only have a maximum of 8 electrons in the second shell. Similarly, I'm going to draw 4 more crosses. So now if you only consider this atom as a whole, so there should be total of 8 electrons in this outer shell. And same goes for this one as well. Okay, question number 5. Hydrogen is the first element of the periodic table. Hydrogen is used in fuel cells to produce electricity in vehicles. Name the substance which combines with hydrogen in a fuel cell. So we know that in a fuel cell, you have hydrogen reacting with oxygen to give us water. Plus, there's some exothermic energy also being released. Okay, so the substance will be oxygen. Now it says name the substance, so do not write the formula. You must give the name. Give one advantage and one disadvantage of using fuel cells instead of gasoline in vehicle engines. Now, there could be multiple answers to this question. You could have multiple advantages, you could have multiple disadvantages. So, one of the advantages can be that water is the only product. Water is the only product, so no pollution. Okay, because usually in gasoline engines, what happens? Carbon dioxide and some other pollutants can also be produced, right? So these are pollutant gases. That is not the case when you use hydrogen as a fuel. Okay, what else can we say? We can actually mention that there is no carbon dioxide being produced. Okay, then the disadvantage could be that it is difficult to store hydrogen, because hydrogen has to be stored under high pressure. It's a gas, right? So unlike liquids like petrol, for gases like hydrogen, they have to be stored under high pressure in special tanks. Okay, so we can say that hydrogen must be stored under high pressure. So definitely, if you have to store it under high pressure, then you also need some expensive equipment which are able to withstand that high pressure. So that is why that's also expensive. But here, make sure you don't give your advantages and disadvantages in terms of cost. Okay, they should be more relevant to some other factors. Like here, water is the only product, so you can say that there will be no pollution. And in this case, you can say it is difficult to store hydrogen under high pressure. Then there could be another important one is that there are less hydrogen refueling stations. So like how you have petrol pumps all over the cities. Okay, you also have gas stations all over the city, but that is not the case for hydrogen. You don't have hydrogen stations, do you? So that is not that has not become common yet. That is why it is a disadvantage. Okay, so the next part will be hydrogen gas can be made from petroleum by a two-step procedure. Petroleum is separated into different components, that is step 1. Then in step 2, large molecules obtained in step 1 are converted into smaller molecules including hydrogen gas. Name the process used in step 1. So when you separate petroleum into different components, this process is fractional distillation. Name the process used in step 2. Okay, when you want to break down large molecules, okay, into smaller molecules that also have hydrogen gas, this is the process of cracking. Because you must understand what exactly are you getting from petroleum? You're getting hydrocarbons, right? You're getting hydrocarbons from petroleum. Those hydrocarbons are large molecules, right? So you're now breaking those hydrocarbons into smaller hydrocarbons. So that is why this is a very specific question. This is not a general question. Okay, organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of the ester methyl propanoate. So this is the formula. 1 mole of methyl propanoate contains 6.02 into 10 to the power 23 molecules. Give your answer in standard form. Okay. Now you can see that this is a 4-mark question. So this is a very heavy question. So this it's a multi-step question, right? So let's first understand what exactly is required. It says calculate the number of hydrogen atoms in 44 grams of the ester methyl propanoate. Okay. Now they've also given you that in 1 mole of this ester you have these many molecules. So that means that we need to first find out that in 44 grams how many moles are there. Okay, how many moles of this ester do we have, so that we can use cross multiplication based on this given information. So moles of ester equal to, because we have been given mass, so therefore we can use the formula mass upon mr. Okay, the mass is going to be 44 grams. Mr we have to calculate. Okay, no problem. How many carbon atoms do we have? We have 1, 2, 3, and 4 carbon atoms. The AR value of carbon is 12. So 4 times 12. Plus, how many hydrogen do we have? We have 3 plus 2, 5, plus 3, 8. So 8 times 1. 1 is the AR value of hydrogen. Plus, now we have oxygen. So we have 2 oxygen atoms. So that will be 2 times 16. Okay. So this would be equal to 44 upon. So let me work this out. Okay, so the MR is going to be 88. So 44 upon 88, that will be 0.5 moles. Okay, all right. So that's the first step. Now, let me write this down. 1 mole of ester gives us 6.02 into 10 to the power 23 molecules. Okay, so how many molecules will I have for 0.5 mole of ester? That would be cross multiplication, right? So we can directly say 0.5 multiplied by 6.02 into 10 to the power 23. 0.5 into 6.02 into 10 to the power 23. So that will be equal to 3.01 into 10 to the power 23. These are the molecules of ester that you have in 44 grams. But that is not the question. The question is how many hydrogen atoms do you have? Okay, so now let's see. 1 molecule of, let me now write down the formula. We have CH3, CH2, COO, sorry, COO, CH3. Has how many hydrogen atoms? We just counted it. It has 8 hydrogen atoms. So therefore, in 3.01 into 10 to the power 23 molecules, how many atoms will you have? That will be 8 multiplied by 3.01 into 10 to the power 23. Just simple ratio, nothing more. This is not a very complicated question. Okay, you just need to understand that, okay, how things are connected. Okay, so 8 multiplied by 3.01 into 10 to the power 23, and that gives you 2.408 into 10 to the power 24, and that is your answer. So these are the number of hydrogen atoms that you would have in 44 grams of ester. Okay, so make sure that you pause this video, go through it, and also try by yourself by the end. Okay, now it says for each of the homologous series shown, name a member that contains 6 hydrogen atoms. Okay, so each of them should have 6 hydrogen atoms. So we need to give an example of an alkane. Okay, so the first one that we have is methane, right? That is CH4. The second one is ethane, which is ethane, right? The second one is ethane, so it has 6 hydrogen atoms. So therefore we can write the name ethane. For alkenes, now we know that in alkenes we have CnH2n. That's the general formula, right? So that means this would be C3H6. Okay, so you have six hydrogen atoms in propene. Alcohol. Okay, let's see. The first alcohol is methanol, which will be CH3OH. So here you have four hydrogen atoms. Okay, the next one is methanol. So that is CH3, CH2OH. So if you count this, you have three hydrogen plus two, that is five, plus one, six. So this is the right one. So we have ethanol. Now, carboxylic acid. Okay, so in carboxylic acid, what's going to happen? You have to, or again, the same thing goes, right? So you can first start with methanoic acid. So that would be HCOOH. Here you have only two hydrogen atoms. The second one will be um, ethanoic acid, which will be CH3COOH. So here you have four hydrogen atoms. Okay, we move to the next one, which is propanoic acid. So that will be CH3, CH2, and then COOH. So here you can see we have 3 plus 2 plus 1, 6 hydrogen atoms. So therefore, this will be propanoic acid. All right. Part E is unsaturated alkenes are converted into saturated alkanes by reaction with hydrogen gas. State why alkenes and alkanes are hydrocarbons. Okay. So we can say because they contain carbon and hydrogen only. Make sure you write this word. If you do not write this word, you're going to lose a mark for this. Okay. Then it says state why alkenes are unsaturated. So why alkenes are unsaturated? Because, okay, first of all, what do we mean by unsaturated? Unsaturated basically means that not all the bonds in the compound are single covalent bonds. Okay, let me repeat. Unsaturated means, okay, let me repeat in this way. Saturated means that all the carbon to carbon bonds that you have are single covalent bonds. That is what saturated means. Unsaturated means that not all carbon to carbon bonds are single bonds. So here we have to mention that why alkene is unsaturated, because it contains carbon to carbon double bond. Then it says name the catalyst needed to convert alkenes into alkanes. Okay, first of all, let me write down what equation, or sorry, what reaction is this? Let's say we have ethene. When you react ethene with hydrogen under certain conditions, then what happens? You would get ethane. So this is the reaction that's going on. For this reaction, there are two conditions. One of them is high temperature. You don't need to memorize that what is the temperature range, just high temperature will suffice. The second one is the nickel catalyst. That is what you need to know. And that is what here the question has asked you to mention. So this will be nickel catalyst. Explain why the conversion of alkenes into alkanes is an addition reaction. Whenever the question asks you that, okay, why this is an addition reaction, or define addition reaction, addition reactions are those reactions in which you get only one product, nothing else, no byproducts. And these addition reactions, they happen only in alkenes, not in other homologous series. Okay, so therefore we will say that mm, um, explain why the conversion is an addition reaction, because only one product is formed. Okay, all right. Question number 6. Natural polyamides are polymers made from amino acid monomers. State the type of polymerization reaction that occurs when natural polyamides form. So this will be condensation polymerization. Okay. The next one is state the term given to natural polyamides. Now, natural polyamides, okay, that will be protein, because you also have synthetic polyamide or man-made polyamides. So there's an example of that could be nylon. All right. So there will be this will be protein. Then it says an amino acid is represented as shown in figure 6.1. Complete figure 6.2 to show the general structure of an amino acid. Show all of the atoms and all of the bonds in the functional group. So basically, you have to give the displayed formula. Okay. Now remember, the general structure of amino acid is that you have a carbon, and carbon has four bonds. Each bond is with something different. One of the bonds is with hydrogen, that is already given to you. The one of the bonds is with amine group. Okay, so one of the bonds is with an amine group. So this is your amine group. One of the bonds is with a carboxylic acid functional group. Okay, you can say carboxyl group. So that will be COO, C double bond O, and then OH. Okay, so that is another one. And the third, or sorry, the fourth bond is with R. Now this R is actually an alkyl group. This is an alkyl group. An alkyl group could be, let's say that you have methane, right? Just remove one hydrogen, you'll be left with CH3. That is methyl group. If you have ethane, okay, remove one hydrogen, so you're left with C2H5. This is ethyl group, and so on. So these are basically represented by R. Okay, so this is the general structure of an amino acid. Okay, so here make sure that you have represented all of the bonds, and all the bonds and all the atoms are shown clearly. So yes. Now part D is three different amino acids are represented as shown in figure 6.3. So this is amino acid A, this is B, this is C. Okay. Now again, these different boxes, they are some sort of carbon chain. Okay, but you're not interested, you're not required. We are not interested, and you are not required to know what that is. Okay. So we can just say that this is some carbon chain. Okay. So because these are different carbon chains, that's why you have they are represented in three different colors. Complete the diagram in figure 6.4 to show the part of the structure of the natural polyamide that forms when the three amino acids combine. So when the three amino acids will combine, you will get a polymer which is protein. Okay, show all of the atoms and all of the bonds in the linkages. Now, when these amino acids combine, what happens? Let us start with this side first. You have NH2, right? So what happens is one of the hydrogen gets removed from here, because that hydrogen has been dropped, and now this bond will be with something else on the left hand side. So with this, we are only showing that there's a continuation. Okay. Now over here you have COOH. From here you have carbon to oxygen double bond. This OH will drop. So from every one of these amino acids, one of the hydrogen is going to drop. Okay, and the OH group will drop. Hydrogen will drop, OH group will drop. Hydrogen will drop, and OH group will drop. Okay, what do I mean by being dropped is that the hydrogen from here and OH from here, they will combine to form water molecule. Okay, so that's what we mean by that. Now what happens from this side? You dropped or you got rid of hydrogen, right? So now this partial amine group and this partial carboxyl group will attach together. Okay, and let me just draw hydrogen in this form. You can also draw in that way, there's no problem in that. Okay, so this now forms an amide linkage. Okay, now the similar concept is going to repeat over here. Okay, the same story is going to repeat throughout the structure. So over here we have C double bond O, and then we're going to show a continuation. Okay, so this is how we have to mention it. Now understand how the marks are distributed. First, you have to correctly show the amide linkages properly. Okay, so if you have shown both of them correctly based on what the amino acid structure has been given to you, then you're going to secure 2 marks over here. The third mark will be for this one, that you have to show continuation at the end. Okay, you have to show that this is not just the end of it, this same pattern is being continued with other amino acids as well. So this is the complete answer, or the complete uh, polymer structure that is required from you. Okay, part E. A mixture of the 3 amino acids can be separated and the amino acids identified using paper chromatography. Complete the equation for RF. Okay, now the RF value can be found by using the formula distance traveled by solute divided by distance traveled by solvent. Okay, then part F. A sample of the mixture of the 3 amino acids is placed onto the baseline and a chromatogram is allowed to develop as shown in figure 6.5. The finished chromatogram is shown in 6.6. So this is the start of the experiment and this is the end of the experiment. The amino acids A, B, and C are colorless. Water is used as the solvent. Explain why the baseline is drawn in pencil. Okay. Now look, the question did not ask you that why it is not drawn in ink or why it is not drawn in pen. So your answers should do not have to mention anything about the pen. Okay, so don't say that okay, because the pen contains different inks and it will dissolve, therefore we're not using it. The question did not ask you about the pen, it is asking why pencil is used. So give your answer in terms of the context. So you will say that pencil mark is insoluble in the solvent. So you have actually given the same answer, but you have given in the right context that, okay, we are using pencil because whatever line, whatever marks you're going to make on the chromatogram, it will not be washed off because that pencil mark is going to be insoluble. State the type of substance, state the type of substance used to make the colorless amino acids visible on the chromatogram. So here we are going to use locating agent. So whenever we have colorless spots or we are using colorless substances during chromatography, we have to use locating agent to reveal the spots. Explain why in figure 6.6 only 2 spots are seen from the mixture of 3 amino acids. Okay, this is an interesting question. It says that we had 3 amino acids, okay, and you can only see 2 spots from here. Okay, now one of the common incorrect answer is going to be that the third amino acid was insoluble, so it did not travel up. The reason why that could be incorrect is because even if it was insoluble and it could not travel up, you would still see that spot over here. I mean, that spot would still be seen on the baseline, right? Because it has not traveled up, so you were supposed to see that spot on the baseline, but you are not seeing that. So that actually means that 2 of the spots might be overlapping on one another. So 2 amino acids might have the same RF value. Okay, so that is what we can write over here. So we can say that 2 of the spots, or you can say 2 of the amino acids have the same RF value and hence they overlap. Okay, Suggest how the experiment can be changed to separate all three amino acids. Now, because you're getting same RF value for two of these spots and you want them to be separated, so you can just use a different solvent. If you use a different solvent, making sure that that solvent is able to dissolve all three of them, all three of the amino acids. So you can use a different solvent, and then based on that solvent, you will get three different spots. Use a different solvent. Okay, that is the end of our question paper. I hope that this video was helpful. So make sure that you stay tuned for some more upcoming videos. Till then, take care. Assalamu alaikum.